Okay, hi everyone, welcome back to this video series on data centers, EIGRP. The Enhanced Interior Gateway Routing Protocol is used in some data centers, although most enterprise companies are moving toward open standards protocol. Configuration with EIGRP isn't all that different from the RIP configuration that we just completed, except we need to add the autonomous system. Check this output. Nexus 7K config feature EIGRP, Nexus 7K config router EIGRP, John EIGRP, Nexus 7K config router AU authentication autonomous system, Nexus 7K config router autonomous system 165535 local AS number, Nexus 7K config router autonomous system 100, Nexus 7K config router INT E3/1-2, Nexus 7K config IF range IP router EIGRP, John EIGRP. This configuration is almost exactly the same as the RIP configuration. It's pretty simple and straightforward. We basically just added the AS number, which has to match all the other routers we want to share routing information with. We'll use the show IP EIGRP and show IP route commands to verify the configuration. Nexus 7K config if range SHIP EIGRP IP EIGRP AS100 ID 172.16.10.1 VRF default. Process tag John EIGRP. Status running authentication mode none. Authentication keychain none. Metrics weight K1 equals 1, K2 equals 0, K3 equals 1, K4 equals 0, K5 equals 0, IP proto 88 multicast group 224.0.0.10, INT distance 90, EXT distance 170, max path 8. Number of EIGRP interfaces 2, 0 loopbacks. Number of EIGRP passive interfaces 1. Number of EIGRP peers 2. Graceful restart enabled. Stop routing disabled. NSF coverage time limit expires 120/0. NSF route hold time limit expires 240/0. NSF signal time limit expires 20/0. Redistributed max prefix disabled. The output of show IP EIGRP gives us the following: the AS number, the process tag John EIGRP, the IP protocol field number 88, the multicast group address 244.0.0.10, the maximum paths value of 8, the amount of equal cost links EIGRP will load balance across by default. You can tweak this amount up to 16 links. Let's check out the routing table now, again using the show IP route command. Nexus 7K config IF range SHIP route output cut 0.0.0.0/0 ubest mbest 1/0 via 172.16.20.2 ETH 3/2 1/0 00:26:35 static 172.16.10 16.0/24 ubest mbest 1/0 attached via 172.16.10.1 ETH3/1 0/0/00:33:53 direct 172.16.10.1/32 ubest mbest 1/0 attached via 172.16.10.1 ETH3/1 0/0/33:53 local 172.16.20.0/24 ubest mbest 1/0 attached via 172.16.20.1 ETH3/2 0/0:33:28 direct 172.16.20.1/32 ubest mbest 1/0 attached via 172.16.20.1 ETH3/2 0/0:33:28 local 192.168.10.0/24 ubest mbest 1/0 via 172.16.10.2 ETH3/1 90/28416 00:00:18 John EIGRP internal 192.168.20.0/24 ubest mbest 1/0 via 172.16.20.2 ETH3/2 90/217 0112 00:00:18 EIGRP John EIGRP internal Nexus 7K config if range OSPF. The open shortest path first protocol has become the de facto standard in data centers and its configuration to keep things simple with this introduction by focusing on the basic configuration using a single area. Let's configure our network with OSPF. We're going to place all interfaces within area 0 since multi-area OSPF is beyond the scope of this book. Nexus 7K config if range feature OSPF Nexus 7K config router OSPF TJ OSPF Nexus 7K config router INT E3 /1-2 Nexus 7K config if range IP router OSPF TJ OSPF area 0. First we enabled this feature, then created a process called TG OSPF. The process ID name is irrelevant. Last, we added the OSPF process to the interfaces we wanted to route. OSPF configured the area ID. This simplified OSPF configuration for NXOS is actually very similar to RIPs and EIGRPs, and it's a whole lot simpler than configuring OSPF for an iOS. It's also easy to verify this configuration via the show IP OSPF command. Nexus 7K config if range SHIP OSPF routing process TJ OSPF with ID 172.16.10.1 VRF default stateful high availability enabled grateful graceful restart is configured, grace period 60, state inactive, last graceful restart, exit status none, supports only single TOS/TOSO routes, supports opaque LSA, administrative distance 110, reference bandwidth is 4000 Mbps, initial SPF, schedule delay 200.000 ms/ECS, a minimum inter SPF delay of 100.000 ms/ECS, maximum inter SPF delay of 500.000 ms/ECS. Initial LSA generation delay 0.000 ms/ECS, maximum inter LSA delay of 500.000 ms/ECS, maximum inter LSA delay of 500.000 ms/ECS, minimum LSA arrival 100.000 ms/EC, maximum paths to destination 8, number of external LSAs 0, checksum 0, number of opaque LSAs 0, checksum 0, number of areas is 0, 0 normal, 0 stub, 0 NSSA, number of active areas is 0, 0 normal, 0 sub, 0 NSSA. The resulting output doesn't provide as much insight as RIP and EIGRP did, but it did provide the following important information: process ID, router ID, which is used to define our router to OSPF neighbors. Now, before I can show you the routing table, we'll need to disable the EIGRP feature in the NXOS because EIGRP has a lower AD than OSPF 90 versus 110, so OSPF routes won't show in the routing table. However, since OSPF's AD is 110, which is lower than RIP, we can keep RIP running on our sample network. Never ever keep RIP running in the background on your production network. We're going to use the no feature EIGRP command to bring up the route table and allow OSPF to propagate in the network. Nexus 7K config if range no feature EIGRP. Nexus 7K SHIP route output cut 0.0.0.0/0 ubest mbest 1/4/0 via 172.16.20.2 ETH 3/2 1/0:00:38:05 static 172.16.10.0/24 ubest/mbest 1/0 attached via 172.16.10.1 ETH 3/10:0:45:23 direct 172.16.10.1/32 ubest mbest 1/0 attached via 172.16.10.1 ETH 3.1/0:00:45:23 local 172.16.20.0/24 ubest mbest 1/0 attached via 172.16.20.1 ETH 3/2 0/0:44:58 direct 172.16.20.1/32 ubest mbest 1/0 attached via 172.16.20.1 ETH30/2 0/00:44:58 local 192.168.10.0/24 ubest mbest 1/0 via 172.16.10.2 ETH3/1 110/40/401 00:00:48 OSPF TJ OSPF intra 192.168.20.0/24 ubest mbest 1/0 via 172.16.20.2 ETH30/2 110/464 00:01:28 OSPF TJ 0S OSPF intra nexus 7k config if range hash. So while it's true that basic routing protocol in configuration on the Nexus OS is a bit different from what you're used to, by looking at the running configuration of our Nexus 7000 using the show run command, we can see that our interfaces are configured with both OSPF and RIP, with only OSPF injected routes in the routing table because of AD. Remember, I just disabled EIGRP so that protocol configuration does not show on the interfaces. Output cut interface ETH3/1 IP address 172.16.10.1/24 IP router OSPF TJ OSPF area 0.0.0.0 IP router route Todd RIP no shutdown interface Ethernet 3/2 IP address 172.16.20.1/24 IP router OSPF TJ OSPF router 0.0.0.0 IP router RIP Todd RIP no shutdown output cut router OSPF TJ OSPF router RIP Todd RIP IP address IPv4 unicast IP route 0.0.0.0/0 172.16.20.2. Even though there doesn't seem to be a whole lot to see here, you can use this output to verify the process tags on your interfaces. Doing this has come in really handy when I've had to troubleshoot my networks. By verifying the configurations on my Nexus 7000, I found typos between the global configuration of the routing protocol and the process tag configured on the interface, which was the reason I wasn't receiving route updates. Summary: this chapter covered IP routing with default routing and dynamic routing protocols. It's extremely important that you really understand the vital basics we've covered in this chapter, because everything that's done on a Cisco router typically has some type of IP routing configured and running. First, you found out how to configure default routing. Then we configured our Nexus lab with a default route. I discussed RIP and how it works within an internetwork, which is not well at all. I demonstrated how to verify RIP. Then we added RIP RIP to our little internetwork. You then learned about EIGRP, a hybrid of link state routing and distance vector protocols that Cisco often refers to as an advanced distance vector protocol. EIGRP allows for unequal cost load balancing, controlled routing updates, and formal neighbor adjacencies. You saw how EIGRP uses the capabilities of the Reliable Transport Protocol, RTP, to communicate between neighbors and utilizes the diffusing update algorithm dual to compute the best path to each remote network. This chapter also provided you with the information about OSPF. It's really difficult to include everything about OSPF because it can be really complex. So I'm going to leave it here today for this video. If you like listening, please consider like, sharing and subscribing. Thank you.